Hello everyone, Dr. Gevrek here. This is chapter 3, labor demand. We are in part 2 where we will learn about profit maximization and we are focusing on short run hiring decision. So let me talk about short run. Short run is a period of time that is too short to adjust at least one factor of production. We assume that in the short run, the capital is fixed and labor is the variable input that we use. Okay, so example for a short run for a bakery, we talked about bakery example in previous part 1, could be a oven, because that is example of a short run is that when the bakery cannot change the oven, right? It's the capital. It takes time. Let's say you have a bakery, you ordered a new oven. It takes time for those kind of things to ship. Once they ship, it takes time to actually add it to your kitchen and customize your kitchen. But you can fire people really easily. So labor is your variable input. Capital is your fixed input. Once you can change those inputs, once you can change your capital, you are now in the long run. Another example for a short run for instance, factory. In the short run, they're fixed by the factory space and all the machinery, heavy equipment they need. So in the long run is the period where they can expand their factory. Okay, so we're now focusing on short run decision making. So we talked about this. A firm's main objective is to maximize its profits. How do we define profits? Profit function, we can use the Greek letter pi, right? Total revenue minus total cost. TR for total revenue. So this is total revenue. This is the total cost. I'm going to just put T for total cost, okay? So that's your profit. Total revenue, the first item is price times quantity. For quantity, you can write down, actually, remember we learned about the production function. Production function is like a machine. You put certain quantities of workers and capital together and it produces a certain level of output, okay? So for quantity, you can plug in just FEK. Price is the market price of whatever you're selling. Total cost is going to be, if you're using employment and capital, which is labor and capital, as the wage rate times number of workers employed plus, this is what we call rental rate, R, times capital. So this is the price per capital, okay? So we are going to maximize profits by choosing employment level and capital, and we're going to maximize this profits function. This profit function, your profits, is going to be a function of both. This is a long run profit function. Why? Because capital is variable too. So price times for quantity, I'm going to put F of production function. For instance, do you remember, what have I done? Do you remember the example from previous part? We actually were producing cookies and we didn't have capital. So because that was a short run production function. But this is long run minus cost of employment, workers, minus rental rate times number of units of capital. Okay, so we're going to assume that firm is operating in a perfectly competitive market. Perfectly competitive market is characterized by many buyers, many sellers, but many sellers, okay? They're producing an identical product and there's no entry barriers. So they are price takers, okay? So perfectly competitive firms, they're price takers. They cannot influence the price of output or inputs. Their inputs are labor, employment, and capital. Okay, so we learned about exogenous and endogenous variables in previous chapters. Exogenous variables here, given variables, okay, are price of the product you're selling, wage rate of workers, and rental rate of capital. These are given from outside. And your choice variables are going to be like, what am I going to decide on? You're going to decide on how many people to hire. You have employment and capital, okay? So these P, W, and R are exogenous, given, you can't change those. Q, which has employment and capital in it, right? Q, you're going to determine Q by choosing employment and capital. So your choices are employment and capital. So let's talk about short-run hiring decision. Short-run is a period of time that's sufficiently short that firm cannot adjust capital. So this is the example we were talking about. Capital is what we say fixed. Okay, if capital is fixed, your output is going to vary, change with employment. So we put a bar here. This bar means it is fixed. That means I have one oven to cook my cookies. Okay, or I have 100,000 square foot factory space to produce cars. Okay, so you can write down your production function as f of e, only depending on employment, your output. Just like this cookies example. Remember bakery? You only have seen employment changing, right? This is a production function, folks. The first two columns show you production function. Okay, moving on. All right, where were we were right here. How many workers to hire? So choosing the employment level is your main question here. Okay, so we're going to maximize our profits. Profit function is going to be a function of employment only. Why? Because price times production function is not EK. It doesn't depend on employment and capital, because capital is fixed. It's like a constant number. It's going to depend only on employment. Okay, minus WE. Why? Because RK is irrelevant. This guy is fixed. Rental rate is fixed. I don't get to choose this. This is given, almost like a sunk cost you have now. All right, so how to maximize profits? I'm going to show this to you graphically, and I'm going to show this to you in terms of calculus. Don't be scared, we got this. Okay, so the profit function, I want you to understand this is in terms of dollars. Profit function, right, is can be drawn in this plane where you have employment. This is short run profit function, 0 people employed versus 1, 2, 3, blah, blah. Profit function is your profits, dollar, measured in terms of dollars. Boom. Profit function looks like this, folks. You know, it starts somewhere here, 0 probably. PE, which means profit as a function of employment, is equal to price times. I said P, I meant to say pi, pi E. Okay. Price times F of E, output, right? This is Q. Price times whatever you, however units you just produced, minus total cost of employment. Profit function is a concave, which means like an upside down cereal bowl, and it's an increasing function. So profits are maximum at this top point. Okay, profits reaches to the top mountain. I'm trying to climb to the top of the mountain, and for instance, this is your maximum level of profits. These hiring these many people, whatever this E star is, I don't know, I made up a number, 527 people will actually maximize your profit. So how did we find this number, right? We're gonna get there. So here I am trying to climb to the top of the profit function. Here's the thing. At this point, what is the slope equal to? Slope at this point, at the maximum point, it's equal to 0. Okay? And what's the slope of, so if I find the slope of P, profit function, and you better make it equal to 0. Okay, so slope of the profit function, folks, is first derivative calculus, first derivative of pi with respect to employment, and equalize it to 0. Okay, great, let's do that. So we're going to, so it's like first derivative means find a change in profit function with respect to change in employment, or change, I'm going to put change for fun right now, equalize it to 0. However, this change is a discrete change, 0 to 1 change, but because this is a continuous function, instead of this Greek letter capital delta, we are going to use little delta, little d. This is the same thing, right? This is also for change, but this is a discrete change, one more unit, one more unit. This is more infinitesimal change, like epsilon, small change, same idea, okay? So let's take derivative of pi with respect to e. So change in pi, profit function, which is a function of employment with respect to employment. In plain English, do you know what we're doing? We're going to look at the impact of change, of infinitesimal change in employment on profit, and equalizing it to 0. Whenever it's 0, then you have found the correct E star, the best profit maximizing output level. So let's do this. I am going to take derivative of this one. So the whole thing, okay? But I'm going to do piece by piece. So I can do first derivative of PFE, right? The first item. I'm going to put this in parentheses, bigger brackets, okay? DE minus WE, so it's WDE over, I'm going to write them together so it won't look, hold on. I'm going to keep it consistent what we did. So I'm adding one more step to my notation. However, I like to explain it well. The WE, okay, divided by DE. So anytime you see like a constant, right, constant number, for instance, this guy here, P, oh, it's eraser, highlight. Okay, so P times something that's a function of E, W function of E, okay, they will come out of the differentiation operator, okay? So it is P of change in FE, I don't know the shape of the production function, okay, divided by DE. If you're having trouble with first derivatives, or you want to learn more just for future reference, email me. I'll be sending you some videos, okay? So this one, W, so the derivative of, let's say E means E raised to the power 1, okay? So I want to show you in terms of X. Let's say we have X raised to the power 2. X raised to the power 2. Hopefully I can draw it. Okay. So derivative of this with respect to X is very easy to find. Throw this 2 up front. Okay. 2x. And put the power 2 minus 1. So this is going to be 2 minus 1 power 1. The first derivative of x squared is 2x. How does it work with x? So x's power is x raised to the power 1. Put that power up front, 1 times x. Then you put the original power 1 minus 1. This is power 0. Anything to the power 0 is 1. Okay? So the derivative of x with respect to x is always 1. Alright? So I hope it helps. What's the derivative of 5x raised to the power 3? So that's 5 times 3, 15. Throw this power up front and lower it by 1 unit. X raised to the power 2. Okay? So here I have WE. So W comes up front. E, the derivative of E with respect to is 1. So I have this guy, and this needs to be equal to 0. I'm getting there, I promise. Okay? So you remember we had to find the slope. We had to equalize the slope to 0, and the slope is 0 when we have this. So I'm going to make some space. let's make some space here. Why not? Okay, I'm going to actually rewrite this whole thing up there. Okay, so I have price times this thing. What is this thing? This is the change in output when you increase employment by 1 unit. We learned about this. This is marginal product of labor or marginal product of employment minus W equals to 0. So a perfectly competitive firm will maximize profit if price times marginal product of employment, which is value marginal product of employment, is exactly equal to the wages. So remember, labor is worth its output. It applies right here. So again, you don't need to know this derivation, but this is the reason. You don't want to go hire many more people. If I hire so many people, look, my profits are lower. I don't like that. I like this maximum level of profit. So as you keep hiring, your profits will keep climbing up. Then it's going to go down. We're trying to find this sweet spot. Okay, let's erase everything on this slide. So by choosing employment level, calculus, I just showed you everything. So you're going to choose employment level such that price times marginal product of employment. So this is what a worker brings in, exactly equal to the wage rate. So we will choose optimal. Okay, this star, what does it mean? This means it's the best level of employment. We also call this optimal. For some reason I want to say Optimus Prime, but that's Transformers. Best, optimal, or this is profit maximizing level of employment. So how many should I hire to make the most profits? Okay, so it is value marginal product, what they bring in terms of dollar value, exactly how much I'm paying them. So you need to continue hiring when value marginal product exceeds wage rate. Stop when value marginal product is exactly equal to the wage rate. Okay, so here is hiring decision graphically, not the profit map, but hiring decision. So remember, you have dollars here, we have number of workers here. Check this out. This is my value marginal product of employment, value average product of employment. Simply we multiplied marginal product of employment and average product of employment with prices. Okay, so this shows you dollar benefit of hiring one more worker. This is the dollar benefit of average worker. Okay, so imagine, right? Wage rate is 22. So wage rate shows you, and we can draw a line, $22 here. You know, wage rate shows you the cost of one more worker, marginal cost of worker. This is the marginal benefit. Remember, marginal benefit equals marginal cost. You need to be hiring these many people. So here's a warning, caveat. A firm cannot change wages. You can adjust employment because this is a perfectly competitive firm. We can adjust employment to make sure value marginal product is exactly equal to wage rate. Value marginal product will be equal to your wage rate if value margin, this is the wage rate, value marginal product is here. If they intersect. Okay, they intersect in 2 points. We'll talk about that. We never choose this point. We are talking about this point. Okay. So we have 2 points, right? I can either hire one person or 8 people. We will never choose this one person level. We'll talk about that. A profit maximizing firm hires workers up to the point where wage rate, this is the wage rate, horizontal line, is exactly equal to value marginal product curve. But we only pick the value marginal product curve, the portion of it that lies below the value average product curve. So only parts that are relevant is this. Now I'm making it really thick green curve. So if the wage rate is $22, hire 8 workers. The relevant points to consider for hiring decision are the points on the value margin product that lie below value average product. So we want the downward sloping this portion. So just consider this portion of the value margin product curve. Okay. So what if the wage rate, this is important, is $38? Should I hire this level? No. Do you know why? Because this portion stays above value average product curve. Okay. So you shouldn't be hiring 4 workers. Actually, you should be hiring 0 workers. Okay. Cost of a worker is $38. Should we hire 4 workers? No. So what is the, okay, I'm going to clean it a little bit. So what's the highest wage rate I should be still hiring people? $32 will be the highest wage rate you should be paying people. So this orange part of the value margin product curve is relevant for hiring workers. I'll see you in part 3. Don't forget to subscribe. So every video I post, you'll be notified. Also, number 2, don't forget to watch these videos in sequence.